everyone, welcome back again. I'm Sakshi Kesharwal, expert in Ask IITian. So first we have done with the first lecture of whole number, and in that class we have learned about the properties of the whole number, what is a whole number, what is a natural number, and in the properties we have learned about the closure property, associative property, commutative property, distributive property. And then we have learned about that division by zero is undefined. Yes, multiplication of any number with the zero is always a zero, right? Because we have seen that the repeated subtraction, we have seen that there is always a subtraction of a number, right? And what else we have seen? We have seen what is an additive identity. Additive identity is what with a zero, because addition of any number with zero give you the same number. And the multiplicative identity, multiplicative means what you're multiplying the number. We are multiplying some number to give the same number. That's the identity. You get the mirror image of each other, right? So when you multiply the two numbers, so it's like that 2 multiplied by some number give you the 2. That is what number? That's the number 1. That is 2 multiplied by 1. So 1 is what? Multiplicative identity. And we have done all these things in the last lecture. So today what we'll be doing, today we'll be taking up the questions related to it, and then we'll be just I think so that's all in this chapter. And there will be one more thing that we'll be studying today, that is the patterns, right? So we'll be learning some kind of the patterns today, and that's the end of the chapter, right? So let's get started with this. Yeah, so we'll be starting with the whole number. As I told you, there are the weightage and everything we have discussed in the last class. And let's discuss about the questions, that is the questions on the properties of the whole number and the patterns in the whole number. These are the two topics which we'll be covering in the today's lecture, right? So let's come to the illustration. I think so this is like well to do. Okay, so fill in the blanks to make each of the following statement a true, right? So it says that 359 plus 476 is equals to what? 476 plus it will be what beta? 359 or not? Reason will be what beta? Commutative property, right or not? Commutative property, right? Commutative property, that's the position change, right? Now let's come into this position also, that is 1952 is this side and 2008 is on this side. So what will be in the blank? The blank will be equals to what beta? 2008, again the commutative property, right? Commutative property. Yeah. Now let's come into this part beta. Now 90,756 plus 0 is equals to what beta? 90,000, that will be what? 90,758 only. Reason will be what beta? Additive identity, right? You're doing additive identity, right? Additive identity, right? Okay, now it says that over here, now just see, this is like 54,321 plus, let's name this as A, this is 489, this is B, and this will be what beta? This is equals to C, that is 699. So you can do the changes anywhere, right? So right now, that is 54,321 has created the, now who is left out? B is left out, right? B is left out, right? Totally. So this is a B. Right, so what is left over here? That is 699, right? That is 699 is like that. So basically, if you have any confusion still in your head, that is you can write association with always same. So first we learned this, and we have learned this, that is B plus C. And you can also do that. You can just leave the A, B aside. Right now, we have just kept the B in all the bracket. We kept the association with B. B is not that important, right? So you might be thinking that the middle number is always of utmost important. No, it's not important. You can just keep him aside also. So B plus A plus C is also the associative property. So this is what beta? Associative property, right? Associative property. Okay. Now coming to this thing, determine the sum by suitable rearrangement. So first you have to see, like whenever you get the number, you have to see what are the arrangements that you can see around, right? So if you just see clearly that like 53 plus 47 sum up to what beta? 100 or not? Yes, sum up to 100. So what do you mean by this? If it is written like 953 plus, I'm just solving the first part, and this is what? 647. So 47 plus 53 is what? 100? Yes or no? Now 9 and 6 is equals to what beta? 15. So 15 plus 100 is equals to what? 1600. You can do this as mentally, right? So this is equals to what beta? 1600, right? Now what will be step 2? Now this is only left behind. So this is what? 1600 plus 407, right? So you have to just add it up as you know. So 1600 plus 400 is equals to how much beta? 2000, which is equals to what? 2007, right? Coming to the second part, right? It says that now you have to just check which two numbers addition is giving, like if you get some multiple of like 10 or not. Now just give a close observation. It's like it says that 15,409 1 plus 178 plus 591 plus 322. Just give a close observation. See, it is just this 9 and this 91 is going to add up to what? 100, right or not? And this 78 and this 22 add up to what? Add up to what, beta? 22, right? So just I am just doing a suitable arrangement, right? It's like 15,409 plus 591, right? This is the one arrangement, and the second is what, beta? 178 plus 322. Now just give a close observation. This oh my goodness, I wrote 591. Yeah, 591. Now see, this 91 plus 9 is giving you what, beta? 100, right? So 100 and this will be equals to how much, beta? This is equals to what? This is going to be giving you what, 100? Yes or no? So this is 100 and 100 plus say 5 will be how much, beta? This is equals to what, beta? 600. So just add it up. So here you will be what? Getting 0. Here you will be getting 0, and this will be what? This is 5 plus this is like 1 will be carry forward or not. So 5 plus 5 is what, beta? 1 plus 4 is what, 5, and this is 5 is what, beta? 10 again, then again 1 carry forward, and nothing is written. This is equals to what, beta? 16,000, right? Or you can say that 15,409 plus 591. So you can just break like this also, like 15,409 plus like you can just break like this, 409 plus 591. Right. So this and this sum up to what, beta? 100, and 4 plus 9 is 4 plus 5 is equals to what? 9. So 9, if you're going to add 100, like 900 plus 9 will be what? 1,000. Yes. So 15,000 plus 1 will be what, beta? 16,000. Right. So over here, if you're going to add it up, it is what, beta? 2 and 2, like 22 and 78. It is equals to what, beta? 100, and 3 plus 1 is equals to 4. So eventually you will have what, beta? 500, right or not? Yes. Yes, so just add it up. It will be what, beta? 21,000. That's your answer, right? Yeah. Oh, 60. Oh my goodness. Oh my goodness. Oh my goodness. It's not 5,000. It's 500. Okay. Okay, 16,500. That's your answer, right? Yeah. Okay. Using the distributive property of multiplication over addition of the whole number, find each of the following product. It says that now you can do this question as I told you in that way also, like 736, right? So 736 can be written as, now 100 can be written. See, this multiplication can be done by using a distributive property, and this is actually, people say that we learned Vedic maths and this and that. This is only the Vedic maths come from, right? So these are the derivations we do in the Vedic maths only. So can I write this 100 plus 3 or not, right? So now just see, now using the distributive property, beta, what is a distributive property? It's already written over here. That is A into B plus C is equals to what, beta? A into B plus A into C, right? You distribute to A to B and distribute A to C with the addition sign, right? So this will be what? 736 into 100 plus 736 into what, beta? 3, right? So it will be what? 73600 plus you multiply, this is what? 18 ka 109, 9 ka 1, and this will be what, beta? 22008. Now you just give a multiplication. So this is equals to what, beta? 80, and this is 8, this is 5, and this is what is 75,888 is your answer, right? Yep. So this is called your answer, right? Now let's coming to this. Find the values of each of the following just using properties, right? Yeah. So what are the properties you see? Just see, as I told you over there also, as I told you that if the number is written like 54 into 7 plus 54 into 3, right? So you see that 54 and 54 is common, so you have to go with the vice versa. So 54 into 7 plus 3, which is equals to what, beta? 54 into 10, which is equals to what? 540, right? Now, can I give you one more example? As I wrote, like 189 multiplied by 14 minus of like see, you can use the commutative property, minus 4 into like 189, right? So you just see that we have already learned that the commutative property applicable for the multiplication. So if you're getting confused, please write in a sequence, right? So it's written 189 into 14. If you get confused, it is written what? 189 into 4, right? Now can you take 189 as common? So this will be what, beta? Into, if you're not using the multiply also, you can directly write the bracket, right? So this is equals to how much, beta? Into 14 minus of 4, right? So this is equals to what, beta? 189 into 10, which is equals to what? 1890. That's your answer, right? This is the way we should have been doing the question, right? So just see over here, like over here, if you give the first part a close observation, it is written 24,576 into 93 plus 7 into 24,579. This is 79, not 76. So you just see that again we can use the commutative property. It will be what? 24579 into 93 plus 24579 into 7. So can we take like 24579 into 93 plus 7, right or not? So which is equals to what? 24579 into 100. So what happened? It's like that you can just do all these things little with the little times of the practice. You will see that you can do these questions in your head also, right? There is no need to, like, you can just see that 93 plus 7 is what? 100, and both of them are equal. So this is equals to what? 2457900. That's your answer. That's it. You can do this orally, right? But depend, it's like sometimes it's required a little bit of practice. That's all. So it will be what? 2457900, right? So this is equals to what, beta? 24 lakhs 57,900, right? Coming to the second part, right? It says over here again 1568 into 184 minus of 1568 into 84. Again 84. Now what you can do, that 1568 you can take common, again multiply 184 minus of 84, right? So this is equals to what, beta? 1568 into what? 100. So this is equals to what? 1568 into 00 is your answer, right? So this is equals to what? 1,56,800. So this is called the distributive property in a vice versa form. We did the question where we multiplied 763 multiplied by 103. So you can do this question like this also, right? Okay. Now it says that now in each of the following, fill in the blank so that the statement is true. It says that 5,500 plus 7 and 300 minus of 1. So beta 300 minus of 1, let's talk about the first person, that is 500 plus 7, right? And this is written as what? 300 minus of 1 is equals to what? 299 into first part, right? So just see, this is equals to what? This is 299, and this will be what, beta? 507. So again, can I write this as 299 into what, beta? 507 by the commutative property or not? Right? Again by commutative property. Commutative property, right? Now, coming to this part. Now, just give the second part a close observation, right? It's written 888 plus 777 plus 555 is equals to 111 into something, right? So can I write this as 111 into 8? Yes. Can I write this as 1100, I'm saying 111, say 111 into 7, right? Plus 111 into 5, yes or no? So can I take that 101 as a bracket, and this will be what? 8 plus 7 plus 5, yes or no? So this is equals to what? Multiply, so 111 into what, beta? 20. So this blank is equals to what? 20. So can I say this is what? A distributive property? Yes or no? Distributive property, right? Now coming to this part, do I have a slide? No, I don't have a slide. Okay, coming to the third part over here, just see, I'm writing the third part over here. See, third part is over here. It's written 75 into 425. This is equal to what? 7 plus 70 plus 5 plus this into 5. So automatically, beta, this is equals to what? 75 into 425 can be written as what, beta? 70 plus 5, right? And this can be written as what? 400. This has to be wrong. This is something wrong. 485. It's written like, if it is written 85, then you have to subtract 400, like you have to subtract 425 minus of 85. So this is equals to what? 0, and this is equals to what, beta? 34, right? So this will be equals to 340 plus 85. This is the way. But I think so here it should be 2. Let's see what is written in the solution. Yeah, it's 340. That's your answer. Yeah, that's correct. Okay. It says that a grouping housing society, yeah, it says that a grouping housing society constructed 350 flats, right? 350 flats, right? And if the cost of the construction for each flat is rupees like 99,000, sorry, 9 lakh. Oh, my bad. Wrong commas. Yeah. It will be what beta? 9,93,570. Then what is the total cost of construction? Right. So cost of one flat is how much beta? Cost of one flat is equals to how much beta? Rupees 9,93,570. Right. So the cost of 350 flat will be how much beta? Flats will be equals to what? 350 into 999,570. Right. So you can do this question in the various ways. Okay. So you can just break this also like 9 it's 93. Okay, it's 93570. This is hard to break. So can I write this as what? 300 plus 50? Yes or no? So can you use the distributive property, or either you can just do the multiplication? Choice is yours, right? So it can be what? 9 into 570 into 300 plus it will be what? 9 into 93 into 570 into 50, right? So what you do, it's like basically you multiply. So there will be what? Three zeros, right? So 3 into 7 is what? 21. 3 into 5 is 20, 15. 15 plus 2 is what? 17. 17 ka 1 carry, 9. 3 into 3 is 9. 9 ka 1. 9 plus 1, 10. 10, 1 carry. So 3 into 9 is what? 27. 27 plus 28. 2 carry, and 9 into 9. 3 into 9 is what? 27. 27 plus 29, right? This is your answer. Right now you multiply this. There will be two zeros. 5 into 7 is what? 35. 35, 3 carry. 5 into 5 is 25. Then 8 carry, right? 3 carry. Like, I'll write it again. It is 0, 0. I'll multiply. So 5 into 5, 35, 3. Okay, then 25, then 28, 2. And then 15, 15 plus 2, 17, 17 ka 1 carry, 45, 46, 4, then 45, 49, right? So what you have to do, you have to just add it up, right? 570, yeah. 80. So you just keep on adding over here. So this will be what? Just add it up. You just add it up. So this and this, two zeros, you will write it down, right? Now, 0 plus 5, right? So this is equals to 5. Now, 1 and 8. 1 plus 8 is what, beta? 9. Now, 7 plus 7 is equals to what, beta? 14. Carry 1, right? 0 plus 6. So it is 6 plus 1, it will be what? 7, right? I'm directly writing. Now 8 plus 9 is what? 17, 17, and there was no carry. So 1 carry forward, right? So 9 plus 4, 13, 13 plus 1, 14. 14 ka 1 carry, right? It is only 2, so this is your answer. Yeah, this is your answer. Okay, now coming to the patterns, right? What are the patterns, beta? See, we have learned like there are two types of like, first way, let's go with the basic of the patterns, right? Pattern in a whole number, which you will see, patterns in whole number. Yeah. Now, if I give you a single dot, right? So with the single dot, there's only a single dot, right? Now, if I would have given you two dots, the two dots can be just put in a line. That's it. Yeah. Yeah. Now, if I would have given you three dots, three dots can be put like this, and three dots can be put like this. Yes or no? So this is what? In a line. Yes. This, see, one is a special one. So here you can put this in a line, and this you can put in the form of what? A triangle or not? Yes. A triangle is formed if you're going to join this, right or not? Yes. Now, if I would have given you four dots, so four dots will be what? In this form, a dot. Can I put this in the form of like a triangle? Just see, 1, 2. No, you cannot put. Now, can you put this in the form of what, beta? A square, right? Can you see this in the form of square? Right or not? So this is a line and this is a square. Now, if I would like, this is 1, this is 2, this one is 3, this one is 4. Now let's talk about 5. Now, how are you going to put 5? For 5 dots, you can put it in a line, right? 1, 2, 3, 4, right? Now, how you can put 5? 5, you can put it like this is like 5, and you cannot put 5 in the form of a rectangle. No, you cannot put in the form rectangle. If you just want to say this is 5 into 1, that's all, right? Or you can put like this 1, 2, 3, 4, 5. Your horizontal or vertical, but this is it's still a line, right? So it's not a square, it's not a rectangle, so still this is a line, right? Okay, you cannot like see this is a triangle 1, 2, 3, 1, 2, 1, 2. No, it's not, right? So no. So first triangle you got on 1 and 3, like, and the next you will be getting on the 3. So no, over here no. Now let's take the 6. Take 1, 2, 3, 4, 5, 6. This is a one way, right? You can just make this as 1, 2, 3 like this, or you can make 1, 2, 3, 1, 2, 3, or you can make like this 1, 2, 3, 1, 2, 3, and 1. So these two both are said to be what bit? A rectangle? Yes or no? If you just join all these lines, this will be a what? A rectangle, and this will be again a rectangle, and this is what? A triangle? Yes or no? If you're going to join this, and this is what? A line. Yeah, this is line and triangle, right? So if I would have given you like 7, no, I'll take 8. So how you're going to make 8? 8 will be definitely a line, will be definitely will be there. How else you can just organize it? So can you make this in the form of like a rectangle? 1, 2, 3, 4, 1, 2, 3, 4, right? Or you can make this as 1, 2, 3, 4, 1, 2, 3, 4, right? This is a way. Or can you make this in the form of a square? No, this won't be in a square. Can you form this as a rectangle, triangle? No, because the first triangle you got, see, triangle is basically when you get like this is 1, right? First triangle, then 1 plus 2. The next triangle you will be getting 1 plus 2 plus 3, which is equals to what? 6. The next triangle you will be getting like 1 plus 2 plus 3 plus 4, right? So this is how you're going to get the triangle, right? Yes or no, beta? This thing is clear, right or not? So we say that like when we get square, square is like a rectangle, line to you are definitely going to get for everything, right? But how you're going to get the rectangle? Rectangle is basically you can get it for any number, like for any composite number. Let's not take the prime number, let's take the composite number. If you take the prime number, let's take 11, so you're going to make only a 9, right? So with the prime numbers you're going to make with only a line. You cannot make a rectangle, you cannot make a square, right? So first with the prime number, yeah, prime number, lines. Only lines is possible, right? Only lines, right? Now, let's take what will be the, when the triangle will be formed, like triangular thing will be formed. It will be like 1 plus 2 plus 3 plus 4 plus 5 plus 6, and keep on going. You will have to just keep on adding, right? So first triangular you will be getting, first triangular will be what? Triangular will be like 1, right? Second triangular will be what, beta? It will be what? 1 plus 2, which is equals to 3. Third triangular you will be getting it what? 1 plus 2 plus 3, which is equals to what? 6. Fourth triangular you will be getting what, beta? Fourth triangular you will be getting what? 1, 2 plus 3 plus 4. So you have to just add it up. So it will be how much equals to, beta? This is equals to 10. This is how you'll be keep on going, and so on, right? When so on, right? Now, what will, when we will be getting the square? Square will be getting like for the square numbers, right? So one is a special number. One, you, for one is like you can make a triangle. One you can make a square. So like square, square you can make with the square numbers, like 1, then 4, right? This is as 9. This is 14. No, 16, right? 16, and this is 25, and then 36. Can I write this as 1 into 1, right? This, can I write this as 2 into 2? This is 3 into 3, right? This is 4 into 4, right? This one is 5 into 5, and this one is 6 into 6, right? And so on. Then coming to the rectangle. Rectangle you can make with any of the composite number. If you take any of the composite number, with the composite number you can make the rectangle. Now let's take a composite number 6. So you can make a line. Yes, with the 6 you can make a triangle. You can make a, see, these are the special case, but we talk about the composite. Let's take 8. 8 is a composite number. So line and a rectangle, right? So let's take about the composite number. Like for rectangle, you will get by what, bit of composite number, right? Yeah, these are also composite, but yeah, this is a special number. So you can take any composite number and rectangle will be definitely made. Rectangle, right? Composite number, right? Okay. So Now let's coming to this thing. This is again a new pattern. So this is a very nice thing. This we teach this in the class 8th, right? So this is a part of this. Between two successive square number, there exists two n non-square number. That is between n square and n plus 1. They are non-square numbers. Where here is a is a whole number. Here a is a whole number. Now I think so you might be understand like confused what it is written. If I say like what is 1 square and what is 2 square? 1 square is what, beta? 1, and the 2 square is what? 4. Non-zero. Non-zero means what? Non-zero means what? Between 1 and 4, how many non-square numbers are existing? Like 3 and 4. The two numbers exist between these two. Yeah. Now, if I talk about like this is first point. Second point, let's talk about 2 square and 3 square, right? So between 2 square is what? This is equals to like 4, and this is equals to 9. So between them, how many numbers exist? Like non-square numbers, right? Non-square numbers, right? So how many non-square numbers are there? Like 5, 6, 7, 8, 8. 4 are there. So this is 4, right? Coming to what, beta? Like 4 square and 5 square, right? 4 square and 5 square is how much, beta? 16, and this is equals to 25. Now let's give a counting, right? So can I write this as 17, 18, 19, 20, 21, 22, 23, 24, 24? 8 are there. Yeah. So it's like I'll count one again. 1, like 17, 18, 19, 20, 21, 22, 23, 24. 8 are there, right or not? So can I write this there? How many numbers are there? Beta, 8 numbers are there. I'll just give you one more. That's the last. Okay. So just see this. If I write like 5 square and 6 square. So 5 square is equals to how much, beta? 25, and 6 square is equals to how much, beta? 36. How many numbers are there? Just give a counting. 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. 35 tens are there. Yes or no? So can I just say that this is written as, let me change color and just see that, can I write this as 2 into 1? Yes or no? Can I write this as 2 into 2? Can I write this as 2 into 4? And can I write this as 2 into 5? Yes or no? So this is 5. This is what? This is 5. This is equals to n. This is equals to n. This is equals to n. And this is equals to n. So it is what? 2 into 1? 2 into 4, 2 into 5, 2 into 10. So if I'll ask you one question, like how many numbers will exist between like 19 square and 20 square? So you don't need to know what is 19 square and what is 20 square. So how many numbers will exist between them? It will be what? 2 into 19, which is equals to what? 38. That's it. Yes. Now, if I'll ask you a big number also, like 199 square and 200 square, how many numbers, non-square numbers, are going to exist between them? So you have to just multiply 2 into 199, which is equals to what, beta? 398. That's your answer. 398 square numbers are going to lie between them, right? Now, coming to the next pattern, beta, it says that the sum of the first n natural odd number is given by, and this is a perfect square. See, over here, we did in the triangular reason also. See over here, if I'm going to add like the odd numbers, right? So if I add like first like 1, so 1 is like 1, which is written as what, beta? 1 square. Now if I write 1 plus 3, this is first two odd natural numbers, so this is equals to what? 4, which is equals to what? 2 square. Now if I write 1 plus 3 plus 5, which is equals to how much, beta? 9. Can I write this as 3 square, right? Now if I write 1 plus 3 plus 5 plus 9, which is equals to how much, beta? This is equals to what? 16. Yes or no? Which is equals to what? 4 square. Right. Now if I'll write 1 plus 3 plus 5 plus 9 plus 11, which is equals to what, beta? 25, which is equals to 5 square. This is how you're going to get the pattern, right? So if I'll ask you the question like 1 plus 2, 1 plus 3 plus 5 plus 9 plus, sorry, oh my goodness, I missed 7, 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 I missed 7. 5 ke baad you cannot get 9, my bad. Yeah, so this is equals to 7, then this is 7 plus 1, 2, 3, 4, 9, right? This is like, my bad. Okay, so this will be 7 plus 9, and this is equals to what? 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27. What are these values, right? So just count it up, right? So count how many values are there. So this is equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is equals to what, beta? 14 square, right? Right. So 14 square is equals to what, beta? 196. 14 square means what? 14 into 14. When you multiply 14 into 14, which is equals to what? 196. This is the answer, right? Now let's do the questions on this. Without drawing the diagram, find the 10th square. So 10th square will be what, beta? The 10th square will be how much? So 1 square is like, see, 1 square will be 1, 2 square is what, 2, 3 square is what, 3, 9. Yeah, 4 square is what, 16, 5 square is what? So this is equals to what, 10 into 10, which is equals to what, 100, right? Now, what is the sixth triangular number without drawing a diagram? So sixth triangular number will be what? First triangular number, second triangular number will be what? 1 plus 2. Then third triangular number will be what? 1 plus 3. Then the sixth triangular number will be what? Then fourth triangular number will be what? 1 plus 3 plus 4. Then fifth triangular number will be what? 1 plus 3 plus 4 plus 5, right? And the sixth triangular number will be what? 1 plus 2 plus 3 plus 4 plus 5 plus 6. So similarly, there is no need to do all this a step. You can directly jump to what? Sixth triangular number means what? 1 plus 2 plus 3 plus 4 plus 5, right? So if it is asking you 10th triangular number means what? 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. So you just add it up. So this is equals to how much, beta? Added up, this is equals to what? 5, 15, this is 10, 15, and this is equals to what? We did 21. That's your answer, right? We didn't draw the diagram and we got the answer, right? This is equals to 21. Now, can a rectangular number be or also square number? Can a rectangular number be a square number? See, we can say, as I said, that a rectangular number can be a square number. Yes, it is. So can I say that in example? Yes, it is, because if you take a rectangular number can be a square. See, we can say that all squares are rectangle, but all rectangles are not squares, right? So we see this over here, rectangular number. As I said, you can make a rectangular with any of the composite numbers, and the squares are basically like 1, 4, 8, 1, 4, 9, 16, 32, right? So what happened? Like you see that either like 4, 8, these are composite numbers or not, right or not? So yes, it is. So we can say that yes, 4, if you take that 4, or you take like 9, can a rectangular number be a square number? Yes, it will be a 4 or 9 or 16. This is what? It can be a square number. Yes or no? This can form a rectangle and this can be form a square, right? Okay, coming to this, can a triangle number be a square number? Okay, can a triangular number be a square number? So what are the triangular numbers you have? Yes, you can have. There's only one number. Like, see, if you're going to add it up, if you just see right now, you added this. This is 1. This is 3. This is what? 6. This is equals to 10. This is equals to 50, and this is equals to 16. So 1 is what? 1 is like what? A triangular number or not? 1 is what? A triangular number. Yes. So 1 is a triangular number, which is also a square number. Yeah. Can a triangular number be a square number? Yes, because 1 is a triangular number as well as square number, right? Right. And similarly, like 4, 9, and 16, these are composite number. These are rectangular number plus as a square number, right? Okay, so see, 16 is a rectangular number and can also be a square number, right? Now coming to this illustration, write the first product of the two numbers with the difference starting from 4 from in the following order, right? 1, 2, 3, 4, and identify the pattern in the product and write the product and write the next three product, right? So what is like, it says that you have to make the product of these numbers such that the difference is 4, right? So if let's see, like if I multiply 1 and 5, right? So 1 into 5 is equals to how much, beta? 5. Now if I multiply 2 into 6, which is equals to what, beta? 12. Now if I multiply 3 into 7, which is equals to what, beta? 21, right? Then I multiply 4 into 8 is equals to how much, beta? 24. Now just see over here, if I take the difference, like see, 5 minus 1 is what? 4. 6 minus 2 is what, beta? 4. 7 minus 3 is equals to what? 4. And 8 minus 4 is equals to 4. So can you see that there's a difference, right? Now, identify the pattern. So if you see that the pattern, like from 5, then there's a 12. So it's written 5, then it's written 12, then it is written 21, then this is written 24. Can you see that this is dot 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 again? So what is the pattern you see over here? The pattern you see that you are adding what, beta? From here plus 7. From here you're adding plus 9. From here, you are adding what beta plus? No, 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 no. Don't go with this pattern. No, there is like this is only the pattern, right? So this is your answer. No, you're not going to do this. No. Okay. So okay, so see, we have organized, we that is what identify the pattern in the product and write the three products. So we identify, so we needed a difference of the four. So we got the first number, that is 1 and 5, that is 1 into 5, which is equals to a difference is 4. Now we have to find the next three products. So next three product is what beta? These three are the next product. So this is your answer. We're not going getting any difference like any particular pattern like we see in the sequence and series, which we like do some of the like find the missing number. No, we're not finding any kind of pattern because this is plus 7 and this is plus 9 and this is plus 13. No, no, we're not getting any kind of pattern. So according to the question, I was going to tell you something else, but no, it's not going to like make a point over here. So what the question says that you have to make a product of the such numbers as the difference is 4, right? So I multiplied 1 into 5 and the difference is what beta? 4. Now what are like, if you once you found out the pattern from all these numbers, you have to write the next three numbers like in the same way. So I made like 2 into 5, 6 is what? 12. The difference is again 4. Now 3 into 7 is what? Again, like answer is 21, but the difference is 4. So our agenda was to make the difference of 4. That's all we wanted to do, right? Okay. Okay. Wait a minute. Yeah. Okay. Let's do some simple discussion over it. I was thinking what I have to teach, right? Okay. Okay. If I say that is 1 plus 0, option A, then option number 2 is what? 0 into 0. Option C. Okay. Option third is what? 0 by 2. And the option number 4 is equals to what? 10 minus 10 is equals to 0. Then like if I'm asking you which of the following will not represent 0. So just think like this. So which number will going to represent like this? Give a close observation, beta. See, it's like 1 plus 0 is 1. Like 0 into 0 is 0. 0 upon something is what? 0. And then it says that 10 minus 10 is what? 0 upon 2. This is again what? 0. 0 upon something is what? Beta 0. So your answer is what? 1. Now if I'll ask you the second question, beta, if I say that if the product of the two numbers, if I say that the product of two number is equals to 0, this is really important and this is really, really important. If I say that the product of two number is 0, it means I'll write down the question like properly. I think so you're a small kid, so I need to write the question. So write down the question. It says that if the product of two whole numbers is 0, can we say that one or both of them will be 0? Justify through example, right? Right. Just see over here. Now, it says that the product of the two whole number is 0. It means what you multiply, that is A into B is equals to what? 0. So can we say that one of them, say that one or both of them will be 0? Right. So what happened like this? Right now we did an example. So if I write like 3 into 0, your answer will be 0. If I write 0 into 3 is equals to 0, that's true. And if I write like 0 into 0 is equals to what? 0, right or not? So it means what? If the product of the two number is 0, it means what? it is not necessary that all the time the both number has to 0. One number can be a non-zero number. Right now you see that 3 into 0 is going to be giving you 0, right? So these are the three possibilities. Now if I'll ask you one more question. Uh-oh, I did it on the wrong slide. Okay, I'll give you one more question. It says that, okay, if the product of two whole numbers is 1, can we say that one or both of them will be 1? Justify through example, right? Okay, just see this. Over here, just see, it says that the product of the two number is 1. So the product of two number is 1. When is the product of the two number is 1? If I write 2 into 1, beta, your answer is 2, right? And if I write like any number, like 0 into 1 will be what, beta? 0, right? Now if I write like 3 into 1 will be what, beta? 3. So when you're going to get the product of the two number is equals to 1, this is only possible when both the numbers are what, beta? 1 only, right? This is only possible when both numbers are 1, right? So can I say that 1 into 1 is equals to what, 1 or not? Yes, this is the only possibility which we have. We don't have the rest of the possibilities. That's it, right? So that's all for you all people. And if you have any doubt, please ask it on the PDF. That's the badge discussion forum, and ask your doubts with your respective teacher in the class. And I hope you have understood this concept, like the whole number property. And this chapter is very small and easy to go. So this is in this chapter only one part is tough. That is what. That is the pattern, and the rest is everything is easy. That is first. My point is that please try to understand the concept and the logic behind the properties of the whole number. That is a closure property, commutative property, and what is an associative property. So later on, you will be learning the same thing in the integers. You will be learning same thing in the rational numbers. As the classes go on, like as the time goes on, you'll be learning the same thing till the rational numbers, right? So please try to understand the concept behind it, what it is, and the multiplicative identity, additive identity. Please keep it in your mind, because these things will be there for you for class 7, 6, 7, and 8, right? Minimum. And later on, it will be used somewhere. But yes, this will be a part of your curriculum. So please try to memorize these stuff very properly. Thank you so much, beta. Bye bye. See you.